did cover in geometry, law of sines. What you need to make sure you understand in this lesson, though, when we cover law of sines and law of cosines, or when we review those, is why law of sines or cosines exist, why we need to use them versus what we were doing before. So make sure you're understanding that point and then knowing how to use it. Actually, starting out before we talk about law of sines is reviewing how to find the area of a triangle, but there is a way to find the area of a triangle if you know two sides of a triangle and then the included angle. So there's a way to find the area of a triangle knowing that information, so using the trig function sine instead of just using the regular formula 1/2 base times height. So the first example is covering just area, but I want to show you where that formula comes from. So it says here, express the area of this triangle in terms of the sine of angle A. So I'm just going to mark in this triangle, here's angle A. You can see the height of the triangle, that altitude is drawn in and labeled H. The base of the triangle is side length B. So normally you find the area of a triangle by taking 1/2 base times height, or base times height divided by 2, however you think of it. But looking at this and just looking at the right triangle that you see, what is the ratio for sine of an angle in terms of opposite, adjacent, hypotenuse? What is sine? Opposite over hypotenuse. So again, just looking at the right triangle that you see, the opposite would be H. The hypotenuse is C. So I know sine of angle A is H over C. And what we're doing here is coming up with how to find the area of a triangle using sine. So what I want to point out in these two formulas is, notice they both include the height H. So this here, I can rewrite and I can solve it for H, rearrange it so that H is alone. How would I solve that equation for H? What would I have to do to each side? Multiply by C. So that would cancel there. And then I'm going to flip it around so I have H equals. So H would equal C times sine of A. And now that can be substituted in to the formula we normally use to find area for H, since it's equal to H. And you get this formula to find the area. Area is equal to 1/2, still your base B, times the height is now C times sine of angle A. And I'll show two other variations of it. But what it says below what I have typed there, you can use this formula to find the area of a triangle as long as you know the lengths of two sides of the triangle as well as the measure of the included angle. So notice from the formula and then from the actual triangle, it's 1/2 times side length B times side length C times sine of A. So the angle A is included or formed by sides B and C. So there are two other variations because it depends on which two sides and then which included angle you're using. So if there's 3 angles, there's really 3 variations of this formula. So other variations would be if I knew the measure of angle B, what two sides of the triangle would I have to know to find the area if I knew angle B? What two sides would I have to know? So if you know angle A, you have to have sides B and C. So if you have angle B, what sides do you have to know? Well, H is not part of the whole triangle, though. H is part of the right triangle. So C and A. Yep, so you need to know the two included sides. H is just the altitude of the triangle. So I could say if I multiply side A and side C, so 1/2 times side A times side C, and then I would multiply by sine of angle B, since that's the included angle. So I'm trying to help you understand the formula so you're not just memorizing. It's always B times C times sine of A times 1/2. Because if you're given different letters, then students start to think, well, I don't know how to use this because I don't have A, B, and C. What am I doing? So it's understanding two sides and then the included angle. So that's one variation. The third one then, if you have angle C, you'd have to know sides A and B. So I could also have the area is 1/2 times side A times side B times sine of angle C. So 1/2 multiplied by the two sides multiplied by sine of the included angle, if you were to write that into words. So then example 1 is just using this formula. It says find the area of triangle ABC to the nearest tenth if angle A is 31 degrees, side B is 18 meters, and side C is 22 meters. And I would recommend for these problems, you may not need to actually sketch this out for this problem because you have it in terms of A, B, and C already. But any triangle they're describing to you in this section and the next, if it's not drawn for you, I recommend drawing it. So if I were just to draw a triangle ABC, just draw a triangle, label the angles ABC. Remember, angles are usually labeled with capital letters. I also need you to remember in this section, it's important that you remember, so if we have angles ABC, we also have sides with lowercase a, b, and c. And so, for example, side A is always opposite angle A. So this side would be labeled side A. Side B is always opposite angle B. Side C is opposite angle C. That will be crucial when we actually get to using law of signs. If you're setting it up incorrectly, you will get incorrect answers. And you will not always be given a triangle that's already drawn for you. You have to understand how to draw that out. So we are given, in this problem, angle A is 31 degrees. Side B is 18 meters. And then side C is 22 meters. So notice we are given the measure of an angle and then the two sides that include that angle. So the area of that triangle could be found by taking 1/2 multiplied by the two sides, so multiplied by 18 times 22 times sine of the included angle, so times sine of 31 degrees. And then this is just a matter of calculating that on your calculator. And it does say find the area to the nearest tenth, so rounding to 1 decimal place if need be. On your calculator, make sure you can get the same answer. You can type 1/2 in as 0.5 if you'd rather do that. So 0.5 times 18 times 22 times sine of 31 degrees. So I'm getting, it'd be 102.0 because that tenth place would round up to another 10. So 102.0. I should put the 0.0 if it does specify to the nearest tenth to show the tenth place. And then what would the units on the area be? Meters squared. Okay, any questions on that? So it's not about memorizing the formula necessarily, it's about understanding the formula. Two sides, included angle, 1/2 times the measure of both sides times sine of the included angle. Okay, so now we're actually going to get into reviewing law of signs. I say reviewing, I know it's not brand new, you saw it in geometry. So we can actually use these three area formulas to derive or show where the law of sines comes from, or get the law of sines from those three formulas. And then the law of sines, what it's showing the relationship between the side lengths of a triangle and the sines of the angles opposite them. So what I'm going to do is, since all three of these formulas represent the area of the same triangle, I'm going to set all three of these expressions equal to one another. They're all equal to the same area. So I have 1/2 BC sine of A should equal 1/2 AC sine of B should equal 1/2 AB sine of C. So just coming from the area formulas we just came up with, they're all equal to the same area, therefore they're all equal to each other. And then what I'm going to do is I can, since this really is representing kind of multiple equations, three quantities equal to one another, I can get rid of the 1/2 by multiplying all three of those by the reciprocal 2/1, or you can think of it, you're dividing all three of them by 1/2, but that means all of those 1/2s cancel out when they're all multiplied by 2. So you just end up with BC sine of A equals AC sine of B equals AB sine of C. And then all three of these expressions, not all three of them have something in common, but if you made pairs between any of them, they would share something. So for example, like these two share a C, these two share a B, these two share an A. So what I'm going to do next is divide all three of them by A, B, and C, little a, B, and C. So in each of them, two things are going to cancel out. One thing will still be left in the denominator. So for that first expression, the B's and the C's cancel, and I'm left with sine of angle A over side length A should equal, in the middle expression, the A's and the C's cancel, so I'm left with sine of angle B over side length B should equal, in the last expression, the A's and the B's cancel, sine of angle C over side length C, and that is your law of sines formula. Okay, so it just shows that the ratio of the sine of an angle over the side opposite the angle, all of those ratios in a triangle are equal to one another. And this can be used to help us solve triangles. You might also see, if you wanted to write it next to it, law of sines is also the exact same if this entire thing was flipped, if you took the reciprocal of everything. So sometimes you might see the side lengths on top and then the sine of the angles on the bottom. So if you were using law of sines and you set it up this way with your sides on top, sines of the angles on the bottom, that's the same thing. That's still okay. And if you see it written out that way, that's still the same. But what is below that is there's only, or rather, law of sines cannot always be used. So you have to be given certain pieces of information in order to use law of sines. And what you have to be given is the measures of either two angles and the included side, or the measure of two sides and an angle opposite one of the sides. So, or rather, two angles in any side, so angle, angle, side, I should say, or angle, side, angle, where the side's actually included. or the measures of two sides and an angle opposite one of the sides. So we're going to go through some examples. And I'll also point out to you when you're setting up the law of sine, something to look for to know, because you don't have to memorize what cases you need for triangles to know if it's going to work, how you know whether or not it's going to work. And actually, we're only covering today examples where you're given two angles and a side. So we're only covering the two cases, AAS or ASA from geometry. This we're going to be covering tomorrow. This is more of a special case. Okay, so here's though how you use it, why you use it, how you know if it works, and if it doesn't work, then you would need to try something else. So if we look at example 2, it says solve triangle NPQ if angle P is 42 degrees, angle Q is 65 degrees, and side N is 5. So I'm going to sketch a triangle. Doesn't matter what it looks like as long as it's a triangle. And label my angles NPQ. And then label what I'm given. So I'm given angle P is 42 degrees. Angle Q is 65 degrees. Side N is 5. So remember, side N would be opposite angle N. So this is side N, and that's 5. I'm just going to label sides P and Q. So side P is opposite angle P. Side Q is opposite angle Q. So first of all, from geometry, what does it mean to solve a triangle? What is it asking us to find? The sides?
Yeah.
Okay, sides P and Q, and what else? Angle N. So you're finding anything that's not given to you. So we need to find angle N, side P, side Q. How could we find angle N? Yes, the 3 angles in a triangle add to 180. You already have 2 of them. So angle N, if you want to write this down just to remember, would be 180 degrees minus the 2 angles you already have. So minus 42 degrees minus 65 degrees. So that is 73 degrees. Okay, so we have one of our 3 answers we need. And if you wanted to, you could then put that on your triangle as well. Just label it. Question for you. So obviously, based on the lesson that we're in using law of sines, we know we're going to have to use law of sines. Question though, why can't we use SOHCAHTOA for this triangle? Why can't we do what we did before? Because on your quiz, there were problems, or at least one problem, where you had to find a missing side, and you could have used sine, cosine, or tangent. So why can't we do that for this triangle, Cora? Yes, it's not a right triangle. So I'm just thinking back to last year when I covered this in Algebra 2. That's what was getting students confused, especially at the end, is if I have an example that is a right triangle and I have an example that is a non-right triangle, why am I doing those differently? Right triangles, you can use SOHCAHTOA. Non-right triangles, you're going to have to use either law of sines or law of cosines. So that is why SOHCAHTOA does not work for this. So law of sines then is really, I'm just going to write out the law of sines in terms of these variables. So in terms of NP and Q, it's going to look like this. I'd have sine of angle N over side N should equal sine of angle P over side P should equal sine of angle Q over side Q. In order for law of sines to work, in order to be able to use it, you need one full ratio, meaning you need an angle and the opposite side. So because we're only given one side length in this example, we were able to find angle n right away. Since we now have angle n and the side opposite angle n, that is why law of sines is going to work. Otherwise, if that was not the case, that's usually where then you have to try law of cosines. So today, in the problems you have, law of sines should work. But that's, as we move forward, how you know whether or not law of sines is going to work or not. So I'm going to be using this ratio, and you should only use two of these ratios at a time. You're not setting up all three equal to each other to solve for something. So I would have sine of angle n is 73 degrees over side n is 5 is equal to, and then I just have to determine, do I want to find side P or side Q first? I'm going to find side P first. So then I would use angle P. So sine of 42 degrees over, and then I would keep side P just as P. And now I'm solving this for P. How do I solve this for P? Okay, I could multiply by P. Okay, yeah, that would be one way to do it. Multiply both sides by P. This P cancels out. And then I have to multiply by the reciprocal of this to the other side to get P alone. There's maybe a less, that's not wrong, but there's maybe a less messy way to do it. What is this called when you have two ratios equal to one another? Starts with a P. A proportion. And how do you solve a proportion? I can just do cross products. And then I don't have to deal with multiplying by reciprocals of things. So I can just multiply these cross products. So I would have, I'm going to write it this way. This product here would be P times sine of 73 degrees should equal 5 times sine of 42 degrees. And then to solve for P, I just have to divide by sine of 73. So then I usually type this in all at once, or rather I don't type something in and then record a decimal down and then use rounded answers to get my final answer. So I would type this in as 5 times sine of 42, hit enter, keep that in my calculator, divide by sine of 73. Enter, and I'm getting, round everything to the nearest tenth. You need to round, so 3.5 approximately for P. Make sure you're not putting degrees next to it, it's not an angle. And then we would actually do the same thing to find Q. Now, even though I now have side P, I'm still going to use the ratio for sine of angle n over side n because I was given side n. Side P is a rounded answer. So I'd rather you keep this ratio, use sine of n over n, but now we're setting it equal to sine of q over q to find q. So I have sine of 73 degrees over 5 is equal to sine of angle q, which is 65 degrees over side q. Solve for q just like we solved for p. Find the cross products. So q times sine of 73 degrees is equal to 5 times sine of 65. Divide by sine of 73. So 5 times sine of 65, enter, divided by sine of 73. And the nearest tenth, that's about 4.7. And once you've found everything in the triangle that's missing, then you're done. Any questions on that one? Okay, I'd like you to try example 3 then. So solve triangle ABC. If you have angle B is 53 degrees, angle C is 100 degrees, side B is 9. Just hold on a second. I'm actually going to come around. If you have questions on example 3, let me know. I can check with you after example 3. I'm going to pass out the assignment though, and then you have the remaining time to work on it. Example 4 is just like it. It was just an additional example. So if you're also working on that one and you want me to check it, I can certainly do that, but I'll pass out the assignment and you can have about 15 minutes to work on that.